Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, here we go with the next lesson. Today's lesson is called Composing Integers, and what it is, it gives us a fun activity to work on, and it gives us an opportunity to take a look at what happens when we add numbers together and how we can add positive and negative numbers together to get to a total sum. So let's get to it. First of all, a couple of terms for us to make sure that we know the difference between a whole number and an integer. Numbers are it's the basic number system that starts at 0, right? So if you think of all the counting numbers, which we call natural numbers, starts with the number 1, then 2, 3, 4. You know, when you're counting things, how you naturally do that in that order. Whole numbers, you just add the number 0 to that. So the set of whole numbers would consist of 0, then 1, then 2, then 3, then 4, in a counting sequence, counting by ones all the way to infinity. That's a horrible little thingamajigger. Let me see if I can do a better one. Yes, that's fantastic. Okay. So what's an integer? A lot of times, misconception with integers, where we say the integers are the positive and negative numbers. And while integers are both positive and negative, that's not really the best way to describe them, because 0 is an integer, but 0 is neither positive nor negative. So when you say positive and negative numbers, a lot of times people will leave 0 out of that. They also, when you say positive and negative numbers, you can have fractions that are positive and negative as well, and those are not integers, just like the fractions are not whole numbers either. So with the integers, the best way to say it is it consists of all of the whole numbers, the entire set of whole numbers, and their opposites. So 0 technically doesn't have an opposite, but it is a part of the set of integers. So 1 has the opposite of -1. 2 is the opposite of -2. 3 is the opposite of -3. And that set of numbers, just like whole numbers counting to 1 or counting by ones to get all the way to infinity, integers count by ones in the negative direction, going all the way to negative infinity. So all whole numbers and their opposites, this set of numbers, oops, hold on for a second. Did I not do that right? I meant to do ... because that goes all the way to infinity as well. All right, so units of length can be placed one after another in a line to find a measurement of an object's length. Today we will look to how to compose or put together different lengths to create a new total length, and all of these lengths are going to be integer lengths. Okay, so there's a lot of reading to be done here. I would rather just go ahead and describe what we're going to do. Basically what we're going to do is this. We have a bunch of different lengths. And what we need to do is work on adding or subtracting these numbers together to get these total lengths, okay? And the way we're going to do it is we're going to use an online technology, and the word's escaping. We're going to use Cecil and the Tightrope with the CPM program. Now, something to be aware of, a couple things. You can use any of these lengths, but you don't have to use all of them. You can use any one of them multiple times. For instance, if I wanted to go 24 feet and do 2 feet every single time and do it 12 times, I would do 2 plus 2 plus 2 plus 2 plus blah, 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 blah. Okay, so you can use all the numbers, or you can use only a few of the numbers, and you can use them as many times as you want, and you can add or subtract. But actually, I would think of it as adding negatives. So these all are like 2, 4, 8, and 10, but they could also be -2, -4, -8, and -10 if you want to think about it that way. Now, it does say for each crossing, look at least 3 different ways to get the acrobat across. Try and do it about 3 different ways. But the directions are going to be to draw diagrams, and I don't want you to spend all your time drawing diagrams. So you can just draw a diagram of one of your ways. Okay, so with that in mind, let me turn to this page so we have all the lengths, and let's pull up CPM online book. Okay, so this is lesson 2.2.1, and we are on problem number 31, which is crossing the tightrope. And if you feel like reading through those directions, absolutely go ahead and do that. There are resource pages, but you don't need to have the resource pages. There have been years when I printed them out and we didn't even need them in the classroom. So I'm not going to attach this. If you really desperately want this or this, pull it up. It's a PDF form, print it off, and go ahead and use it. Okay, but we're going to go to the Acrobat number line, which is Cecil, our Acrobat. That's Cecil right there. And this is basically what we're going to do. That very first one said you had the options of using 2, 4, 8, and 10 for 24 feet. So here they are, 2, 4, 8, and 10. But you can also go -2, -4, -8, -10. Now watch what happens when I put a few of these together. To go 24 feet, we could just go 8 3 times, correct? And you see how it ends right here at this red ball there? That's the end of the tightrope. So when you press play, it's going to go ahead and do that for you, and it's going to leave behind a diagram for you to copy down, okay? So the diagram starts at the beginning, and then there's an arrow for the direction you're going in, and then the number of feet that you would go. So 3 arrows, all of them all the same length. If I wanted to go 4, 4, 8, 4, 4, that would work as well, right? Because it stops you right here. Press play. And this essentially becomes, do you see that number sentence right there? 4 plus 4 plus 8 plus 4 plus 4 equals 24. You'd want to copy that down and then draw this diagram. Now, something else to be aware of. If you go past, that's okay. You're not going to fall off, because you can always work your way backward. And you see how it's got the negative here and then the next one. So this one's going to end up 1, 2, 3, 4, 5, 6 moves to get there, where you added the 10 3 times. That's 30, plus a -4 is -26, plus a -4 is a -22, plus 2 is +24. Okay, but this would require you to draw your diagram so it went off beyond the endpoint and then came back. The laws of gravity are not applying to Cecil as long as he's in the middle of a routine, but watch where they apply to him. If I thought Cecil could go 10, 10, then -4, then +8, that's not gonna work. Then here, okay, so what is this? 10, 20, 16, 24. This should only be 22, wouldn't it? So watch what happens to him. Oh no! Yes. Half the time, this is the fun of this is just watching him, oops, try again, fall off the tightrope. Okay, so feel free to use this technology to help you. And we're just going to go ahead and move forward, and you will be responsible for drawing these diagrams. And I'll model a couple of the diagrams with how they would look, okay? So have fun with it. Oh, no, I got a model, don't I? I just got done saying that. All right, so let's show, they suggested doing 3 different sequences to get this, but you only have to choose one to model. So this is the one I went with. 2 plus 8 plus 4 plus 10 is 24. So here is what that model would look like. And you don't have to draw the whole tightrope thing. I just got a little creative with my artwork here. But you see how that first one, what do we have here to get across? It's 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of these little segments here is representative of 2 feet. So you have a 2-foot jump, then an 8-foot jump, then a 4-foot jump, then a 10-foot jump. All of them combined, Cecil would make it to the other end, because 2 plus 8 plus 4 plus 10 equals 24. Okay, there are a ton of different combinations you could do for this one. Now let me do the second one. And this one I chose to include a backward step, right? Okay, so you go forward 10 feet, then back 3, so you're at 7. Then you go forward another 10, that stops you at 17 feet. And that's how my diagram looks, okay? So I started at the beginning, I went 10, but when I went back to the left, I had to go down a step. Otherwise, I would, be doing the arrow over top of it, and that would look really messy. Okay, remember what they did here? So it doesn't look messy. If I don't need to go at all backward or to the left, then I can just keep it all in the same line. But here, I had to, oops, stop it. Don't do that. Nice, okay. For this one, yeah, I ended up having like 3 layers to it. You may have some with 4 or 5 layers, depending on the number of times that you go forward and backward. Have fun with it. Remember, Cecil here on the computer can help you with how the diagram should look. Okay. Oh, by the way, I forgot to tell you this. Yeah, this is stuck on the 24 footer. That's A, right? How to get to B? Go up here, click on choose a puzzle, and you got all these options here. So you can go to B, and then you can see how it went plus 10, minus 3, plus 10 again. Is that the winning combination? Yes, it is. And here we've got our number sentence to write down. Okay, so up here, define, choose a puzzle, choose any of these distances. I don't think all of these are here, are they? 24, 17, 15, 27, 23. Yeah, some of the 38 is there for some reason, but you can play with it. And then looks like this one is a 23 as well as that one, but you got some different lengths to work with. So play around with it, have fun. Okay. So I guess at this point, I'll just reveal my last 3. And then you can work on your own all you want. For 15, I went 4 plus 11. For 27, I want 8 plus 19. And this one took me a little time to figure out what to do, but I eventually got it to where I went 7 plus 7 plus 7 is 21, minus 11 or plus a negative 11 is 20 or is 10, and then plus 13 is 23. Okay, so have fun all you want, and pause the video, and when you've made your diagrams, one diagram for each one of them, see if you can find 3 combinations that work, then go ahead and rejoin me. Okay, so problem number 32. To represent the way that an acrobat could move across a span of 17 feet, Mara wrote the expressions below. If each number represents a length in feet, check that each expression would get Cecil exactly to point B. Be prepared to defend each conclusion with a diagram. So go ahead and copy these down and determine, would you, if your tightrope was 17 feet, would you get to the other side with each one of these expressions? Oh, I don't like that. That'd be terrible. All right, and the answer is, for A, yes. 10 and 7 make 17. For B, 7 plus 10, yes, that's 17. For this one, we're just flipping the order. 10 and 7 is the same as 7 plus 10. Yes, it is. It's 17, and in this case, it's a slightly different order than the one that I worked with. I did 10 plus a negative 3 plus 10, but if you went 10 plus 10, which is 20, plus a negative 3, that would also get you to 17. So what does this negative 3 represent? I used it once on part E of the Cecil challenge with the acrobatics. It means you're moving backwards, right? Or on the tightrope, moving to the left as we see it. Okay. So a forward is a positive. A negative would be the going in reverse or going backward. Okay. So when combining lengths, oh, I skipped over problem 33 because it was basically just telling us to do this part that I already told you to do. So I skipped problem 33. When combining lengths to make a new length, does the order of the numbers matter? Okay, so this, we're kind of referencing what's called commutative property here. Commutative property, and that's the property that says whenever you're adding numbers together, it really doesn't make any difference the order in which they're being added together. So if we take a couple of examples, if I rearrange the order of these numbers to get 23, 7 plus 7 plus 7 plus negative 11 plus 13 gives us 23. But if I rearrange some of these numbers, I still have 3 7s, I still have the positive 13, and I still have the negative 11. It's still going to give you 23. It does not matter what order you add these together. Now, if we didn't write this as a plus a negative 11 and we wrote it as minus 11 and we started moving the minus 11 around, actually that would work too, as long as you kept it as a minus 11. But if you move the 11 and the 7 and turn it into minus 7 and plus 11, then that becomes a problem. So as long as you're adding integers together, whether they're positives or negatives, the order will not matter. You'll always get the same sum. All right, and I believe this is our last activity for this lesson. I'll read it out entirely for you, and then you can have a little fun with this too before checking with me to see how your answers are. In problem 31, you found multiple ways to combine lengths to get an acrobat to the end of the tightrope. This time, you have the lengths 2, 5, and 9. And what you need to try and do is see if the tightrope was only 1 foot across, could you use those lengths to get 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, all the way to 10 feet, okay? Remember, you're allowed to go beyond the end of the tightrope and then come back. So it seems like it would be impossible to go 1 foot because any one of these would take you over the edge. But the laws of gravity are suspended for this type of an activity, so you're allowed to do that, okay? So your job is to decide if you can do it. I would make a list, like I've got the list right there where you got all the different numbers, and figure out what combinations of these numbers. Remember, you can use positives or negatives. So 2 or negative 2 are in play, 5, negative 5, 9, negative 9. You're going to write an expression using these 3 numbers, either adding them or subtracting them, adding the negatives, and then prove that the answer is actually 1, 2, 3, 4, 5, and so on and so forth. Okay? Now, I did provide a little bit of a hint here. It's asking, are there any of these that are impossible to get? Okay, so my hint is if you can find a way to get 1, you can get any number because you just keep doing it over and over and over again, right? Because 1 plus 1 is 2, and 1 plus 1 plus 1 is 3, and 1 plus 1 plus 1 is 4. So if you can figure out the 1, you're going to figure out all of them. There is a way. Now, it may be easier to find other ways to do it. For instance, to go, I'll show you my one, is 5 plus negative 2 plus negative 2 is 1, right? Okay, so I'm not going to repeatedly do that over and over and over again. That would just get boring, especially since for the number 2, you could just use the number 2 and nothing else. Okay, so have at it and answer all of A, write out all those expressions, and then also B. And then when you come back after unpausing me, then I'll reveal the answers and maybe discuss this one a little bit. All right, welcome back. Hopefully you found everything. These are my answers. I found one for every single sum here. 5 plus negative 2 is 3. 2 plus 2 is 4. Or you could have, if you wanted to choose. Sometimes I tell students if they think it's too easy, make every one of your combinations include at least one negative number. But I didn't do that myself. 9 plus negative 5. 5 is easy. 6 would be 2 plus 2 plus 2. 7 could be 9 plus negative 2 or 5 plus 2. 8 would be 5 plus 5, which is 10 plus negative 2. 9 is super simple. 10 is super simple. 5 plus 5. All right, so here's the last one. Let's do some critical thinking here. Could you combine the lengths of 2, 6, and 8 to cross a tightrope that was 17 feet long? What do you think? Is that even possible? Why or why not? This is where it's fun to be in the classroom and get some feedback from different students and have them arguing with whether it's possible or not. But in this case, my answer is no. It's not possible. The reason is because anytime you add 2 even numbers together or do a subtraction involving 2 even numbers, you're always going to get an even number, no matter what. You need an odd number in order to have a sum that is odd, right? Look at all of these. To get a sum that is odd, you need to have an odd number involved in those in some way, shape, or form. The even numbers, you could add two odd numbers to get an even number, but you can't add two even numbers and get an odd number. So that would be impossible, all right? How much time did that take? 20 minutes, not too bad, especially the fact that you had paused it and had a little bit of fun. So, all right, good luck on your homework. Cecil, this work that we're doing with Cecil here, we're going to continue doing this work for quite a while. And I'm going to use Cecil as my justification for why we do order of operations the way that we do them. Okay? PEMDAS. There is a mathematical, scientific reason why we do it that way. We did not just make it up and decide everyone in the universe has to follow that. PEMDAS, order of operations, there is a reason why we do the order of operations the way we do them, and Cecil will help me explain that to you, but we'll get to that at some point in the future. We're not going to do that right now, all right? Go do your homework. Take care. Talk to you tomorrow.
Hey, feeling good.